Do you still remember the permutation and combination on the blackboard? We can see from the blackboard there is such a question. It asks if there are a total of 6 colors and use them to paint a cube and use one color for each face. The colors on different faces should be different. Then how many different coloring ways are there? I think all of you have thought about this question. What's the answer? Actually, we just need to use the basic combination and permutation to calculate this question. Let's say we fixed the position of this cube, then its topmost surface, it contains 6 choices. Of course, its corresponding bottommost surface, because we have used up one color, the corresponding bottommost surface contains the remaining 5 colors. And after finishing up the remaining 4 faces, it then made up a ring. Therefore, through the use of circular permutation, we know it is equivalent to 12 factorial divided by 4. Does it end here? But we will realize in actual situation this cube can be rotated, so each face can be regarded as the topmost surface, and this time we need to divide it by 6. This problem told us if the items can be rotated, we need to perform the calculation, which might be slightly different as usual. Although for the particular question, we may use traditional combination and permutation to solve it. What if we modify this question a little bit? For example, we are still using 6 different colors to paint. But for this time, although still each face needs to be painted by one color, but different faces may be using the same color. Everyone will be thought of maybe it contains repeatable elements, and this time, how many different painting ways are there? We will realize if we use only the previous combination and permutation method, it cannot be enumerated completely. Especially when we are under a more complicated situation, we will realize the knowledge that we have is not sufficient to solve the problem. And this time, let's review our previous calculation. When we encounter any difficulty, what will happen? For example, when we started our combination calculation, if we want to find the general term for recurrence relation, we will realize it is very difficult. And this time, we use a new concept, which is applying the form of functions with generating function. Now we will realize our problems for each category has become into the multiplication of polynomials. Well, at the same time, even though we have the basic counting rules, we are required to achieve no repetition and no losses. In actual world, it used to be very complicated. They contains very complicated relationship between each of them. We have also introduced the inclusion and exclusion principle. Inclusion and exclusion principle told us that if we need to categorize the same kind as of how to have inclusion and exclusion. But now it is inside a world which can be rotated. How are we going to do it? We can first not to consider inside a 3D dimension. Let us just take a look at the flat surface. If it can be rotated, what are the possible problems? For example, a square which we used to see we painted its 4 corner points using blue and red 2 colors. How many different painting ways are there? After taking a look, it was just a fixed square. It should not be any problem for corner points. Each point may have using 2 colors, so it will be 2 to the power of 4. But this square can be rotated, so please think about it and complete the following quiz.